audio. And it gave me a warning. I'm not sure why. Is it working now? I think it's working. Okay, perfect. Yes, so we have the quotient rule. Yes, so then r prime of t. I have to square this. So let's refresh our memory. How do we square e to t squared squared? We copy the base. What do I do with these exponents?
Multiply them?
Exactly. Thank you very much. 2t squared. Awesome. So this is e to 2t squared. Great job. Thank you. Now I have to use the formula. Can anyone give us the derivative of the top? And I will put it here and multiply by the denominator.
Half t plus 2?
You mean 2t plus 2. Yes, I agree. Minus. I copy t squared plus 2t, and now I have to be careful, differentiate this and put it here. Can anyone differentiate e to t squared for us? Try it, please. It's okay.
Two et?
Yes, but you have to write, say, e to t squared times the inner function prime, which is 2t. E to a function prime is e to that function times the inner function prime. So that's what I have to write here. Yes, you can write it as 2t, I agree, but e to t squared. Yes, we're going to try to simplify it a little bit. Okay, so I'm going to use a triangle, skip over this, and this continues here. Is there a common factor that I can pull out from the numerator? This is one term, and this is the other term. Is there something that we see in both and I can pull it out? Anyone? E to t squared. It's common in both. I put it out. So then 2t plus 2, and now I have to be careful because I have 2t to be distributed here, but also the negative sign. 2t times t squared is 2t cubed with minus. 2t times 2t is 4t squared, but with minus. Only now, remember this is basically e to t squared times e to t squared. Copy the base, add the exponents. So I can simplify one of those. Put the numerator in the correct descending order, negative 2t cubed minus 4t squared plus 2t and plus 2 over only one of those, e to t squared. And this is it. I like to look at the word problems, because this is good practice to practice the differentiation of exponential functions. And we can also go back and look at the derivative, the second derivative. But I like to look at some word problems. That's why we're looking at derivatives. Why? Why? Well, because of this. Because of the rate of change. That's all we need. That's all we care about in this the first few chapters of this class. The rate of change. That's what we want. Okay. I don't know what you prefer. Would you like to start with the medication concentration?
Yes.
Okay, very good. I'm on page 5. Good. So medication concentration, the concentration C in parts per million, ppm. So this is problem 53. So C is in ppm. We can never forget the measurement unit. Of a medication in the body, T hours. So T is in hours. I'll stop sharing in a second. After ingestion is given by C, function of time, equals 10t squared times e to negative t. Find the concentration after 0, 1, 2, 3, and 10. 0, 1, 2, 3, and 10. And then we can do this. I don't really care for using a calculator to look at the graph, but we will. But I'm interested in this. Find C of 5 and C prime of 5 and explain what those represent. So this is part A, and then part C, C of 5 and C prime of 5. That's why we study these functions, to get to applications. So in order to determine these numbers, the value for these x values, I would put this function in the graphing calculator as you see it, and then plug in these. I'm not going to do it 10 times or 5 times by hand. And I'll also determine this, okay, and also 5. So I can create a table with C of t with 0, 1, 2, 3, 5, and 10, and then put the values underneath. And here they also want C prime of t, but only here. I'm not going to fill in for everything, although we can. So my calculator is ready for you. Here it is, right here. So in y equals, clear anything and everything you have. The function is 10 x squared and e to negative t. You know me, I love parentheses. Okay, so we make sure that this is correct. Yes, 10 t squared e to negative t. Now I go to second and table, and I punch in all these numbers. I want 0, I want 1, I want 2, I want 3, I want 5, and I want 10. I'm not going to do this 15 times, right? I'm going to do it smart. 0 for 1. I don't know if they want us to use 2 decimals, 3 decimals. Are they telling us anything? I'm going to use 2 decimals then. Oh, I didn't mean that. Sorry, I meant this. So 0, 3.68, then 5.41, then 4.48 ppm, parts per million, 1.68, and 0. I'm going to say 0.5. So I filled my table in. Done. So what do these represent? At time 0, the concentration in the bloodstream is 0. Let's say I take an aspirin right now. The concentration in the bloodstream is 0. After an hour, after I took the medication, this is the concentration in the bloodstream. After 2 hours, after 3 hours, after 5 hours, after 10 hours. Okay. Now they're asking us, so this is very clear, but they're asking us to find C prime of 5. What should I do in order to find C prime of 5? What do I have to determine first? In order to find C prime of 5, I have to find what first?
What's C prime?
Exactly. I have to find C prime of t. Absolutely. Good. Let's look at C of t. Let's identify the type of function. Look at C of t and say, oh, I know it's a, so then you have to apply such and such. What is it? I'm going to copy it here. C of t equals 10t squared e to negative t. What is it?
Would it be 20 times?
What is, you're way ahead of me, which it's awesome. But first I need to identify what it is. In other words, is it a sum? Is it a ratio? Is it a product? Is it a square root? What is it? If I don't identify, yes, it is a product. Because it is a product, awesome, I have to use the product rule. Now we can start. Only now. I'm ready. Because it's a product, I prefer leaving 10 alone to wait patiently. I believe, if you understand, 10 will be very patient. It will not go anywhere, I promise you. It will stay there patiently because it's a product. If it's a sum, I cannot take 10 out, but it's a product. It can wait. So now, what do I write? How do I apply the product rule here?
It's f times g prime plus f prime times g, so it would be 10 times 2t times
Let's start one more time.
negative
2t.
Good. Times e to negative t plus t squared. And now we have to differentiate e to negative t. Let's do it on the side. E to negative t prime is, can anyone help with e to negative t prime? E to negative t, good, times the inner function prime. Because it's not 1. Times the inner function prime. Because it's
Negative te.
the inner function prime. One more time.
Negative 1.
-1. Thank you. Negative t prime is -1. This is what I have to put here. So I'm going to write e to negative t times -1. Good. You know me, lazy people do this and jump over the rest because they don't want to write it again. So we're jumping right here. 10 stays outside waiting patiently. 2t e to negative t. But now I have to replace, because I'm multiplying +1 by -1, so I have negative t squared e to negative t. Is there anything I can pull out from those two? And join
e
the,
to negative t.
yes, and also 1t. 1t and e to negative t. T is out, this is out, so I have only 2. This is out, one of the t's is out, minus t. What I would have done, I'm happy with this result, but I don't like the fact that it's not arranged in the correct order. So it will be this, but now I see it's a negative leading coefficient. So I prefer writing this. Yes, I accept this form and this form as well. You will see what happens in the next chapter. I'm preparing you for the next chapter. Good, so now, all these are in ppm. Parts per million, and so on and so forth. The answer for 5, we haven't determined it yet. We do have C prime. All this This is C prime of t. Dot, 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 dot. But now they want us to find C prime of 5. Since I have the function, C prime of 5 will be negative 10 times 5, negative 50, e to negative 5. And 5 minus 2 is 3. So the answer is, I'll have to use the calculator, negative 150 e to negative 5. I have no idea what that means. So negative 150 times e to negative 5. Negative 150 e to negative 5. Enter. So approximately negative 1.01. Now the question is measurement unit, and what is it? What does it represent, and what is the measurement unit? Who would like to help? C is in ppm, T is in hours. First, let's identify the measurement unit. Anyone? Yes?
Where did you get that 3 from?
5. 5 minus 2.
Oh,
Measurement unit. Anyone? Please? Please?
Parts per million.
Careful. These two cannot have the same measurement unit. This is a rate of change, and rate of changes have always 2 measurement units. 2, not 1.
So hours over parts per minute?
Careful. The y variable is in parts per million. The x variable is in hours. I cannot have x variable over the y variable.
So it's parts per million over hours?
Brilliant. Thank you. ppm per hour. Okay, what does it represent? The negative 1.1 ppm per hour. What does it represent? What is the definition of this?
Would it be the rate of change?
Yes,
per-
yes, the rate of change of concentration with respect to time when t equals 5 hours. So 5 hours after I took the medication, the concentration decreases in my system by 1.01 parts per million divided by per hour at that moment. 5 hours. Awesome. Good. That was a very important type of problem to understand how this works. Okay. Let me know if you want to go back to finding a second derivative of any of this. If not, I would like to talk about log functions. You decide.
I was going to ask you if we could do another one like this, like the one we just did.
Yes, of course. What about a growth over retirement fund?
All right.
We are given the function. She has an IRA account. Let me copy it. 1 second. This is 49. And we have V of t equals 20,000 e to 0.0545t. So she invests $20,000 in an IRA account whose value after t years is modeled by this. So for a moment before we read, this is in dollars, this is in years. Measurement unit, super important. Okay, go back. Use the model to estimate the value of the account after 7 years, and what is the rate of change in the value at the end of the 7th year. So allow me to start a new